Here we have a SAT math problem. Okay, let's go to the question. There is an expression over here that is 4th root of x cubed times 12th root of x to the power of 5. The given expression is equivalent to mth root of x to the power of n, where m and n are positive constants each less than 10 and x is greater than 1. What is the value of m over n? Okay, the question says that this expression is equivalent to mth root of x to the power of n. So now we can write the equation from this information, that is 4th root of x to the power of 3 times 12th root of x to the power of 5 is equal to this stuff, that is mth root of x to the power of n. Okay, now what we can do is first we can write this radical as an exponent. Whenever I write a radical as an exponent, the exponent will be a fraction with numerator 1. The index of the radical has to be taken at the denominator. Then we get x to the third power whole to the power of 1/4. I have written this radical as an exponent, that is 1/4. The same thing we can do for this one, that is times x to the fifth power whole to the power of. Now we can write this radical as an exponent, then we'll have a fraction with numerator 1. The denominator of this fraction has to be the index of the radical, that is 12. On the right side, we can write this stuff as it is, that is mth root of x to the power of n. Okay, here a power is raised to another power. Whenever a power is raised to another power, we can multiply the two exponents over here. When I multiply this 3 and 1/4, I have to multiply this 3 and numerator 1. 3 times 1 is 3, that is we get 3 over 4 times the same thing. A power is raised to another power. We can multiply the two exponents 5 and 1 over 12. Then I'm getting 5 over 12 as the exponent for this x equals to mth root of x to the power of n. Okay, here we multiply two powers with the same base. Whenever I multiply two powers with the same base, what I can do is I can take the base ones and add the exponents using the product rule in exponents. That is, we have to take the base x ones and we have to add the exponent, that is 3 over 4 positive 5 over 12. On the right side, we have mth root of x to the power of n. Okay, here we have to add these two fractions, and these two fractions have different denominators, 4 and 12. Okay, now to do addition or subtraction of two fractions, we need to get the same denominator. Okay, here to get the same denominator, we have to find the least common multiple of 4 and 12. The least common multiple of 4 and 12 is just 12. So we have to get 12 as denominator for both the fractions. Already we have 12 as denominator for this fraction. So for the first one, we have to get 12 as the denominator. For that, we have to multiply both numerator and denominator by 3. Then I'm getting x to the power of 3 times 3 is 9 and 3 times 4 is 12 positive 5 over 12. This one can be taken as it is. On the right side, we have mth root of x to the power of n. Okay, here we can take 12 as a common denominator and we have to add the numerators. 9 positive 5 is 14. Okay, here 2 goes into 12 6 times and 2 goes into 14 7 times. On the right side, we can write this stuff as it is. Let me finish. Okay, we get x to the power of 7 over 6 equals to mth root of x to the power of n. Okay, here on the left side, I have to get the radical so that I'll be getting the stuff in this form. Then I can compare and I can get the values of m and n. Okay, how do you have to get this one in this form? So for that, we need radical over here. How do you have to get radical for this one? Okay, now let me write this fraction exponent 7 over 6 as 7 times 1 over 6 equals to mth root of x to the power of n. Okay, here two values are multiplied at the exponent. Whenever two values are multiplied at the exponent, one of the values can be taken as exponent for the base x and the other value should be taken as an exponent for the whole stuff. Okay, here in these two values, let me take the first value 7 as an exponent for x. Then I'm getting x to the power of 7. Now let me take the other value 1 over 6 as an exponent for the whole stuff. Okay, here I'm doing power of a power rule in reverse. On the right side, we can write this stuff as it is. That is mth root of x to the nth power. Okay, here for this x to the 7th power, we have the exponent 1 over 6. Okay, here we have a fraction as an exponent with numerator 1. Then it can be written as radical. When I write this one as a radical, the index of the radical will be the denominator. So that is 6. Then we get 6th root of x to the power of 7 equals to mth root of x to the power of n. Okay, here the stuff we have on the left side is exactly in this form. Now let's compare. At the place of m, what do we have? We have 6, that is m equals to 6. At the place of n, we have 7, that is n equals to 7. Okay, here I got the values for m and n. And also the question says m and n are positive constants, each less than 10. Okay, here I got positive constants as values for m and n, and each value over here is less than 10. Okay, now let's find the value of m over n, that is m over n equals to 6 over 7.